Hmm. Hello students, how are you? Today we will discuss about the topic of law of conservation of motion of chapter 5. In this chapter I have already explained you about the Newton's law of motion. There were three Newton's law of motion: law of inertia, which is first law of Newton's law, in which if every object is in rest, it will remain in rest condition, or if any object is in uniform motion, it will continue its motion. Until and unless if we are not applying the external force. Second law of Newton's told about the rate of change of momentum, and third law you everyone know we have done to the experiment of third law of Newton, which is action and reaction. Okay, today I will discuss about the law of conservation of momentum now. What is the law of conservation of momentum? Law of conservation of momentum says if there is no external force applied on an isolated system or a system, then the total linear momentum is the vector sum of all the momentum or momenta of all the particles individually. The total linear momentum is the vector sum of linear momentum of all the particles of the system. Here we will write and we will prove it by mathematically. Okay, derivation here. Suppose I have two objects or two balls, A and B. A has mass m1, B has mass m2. Okay, the velocity of A initially is u1 and initial velocity of object B is u2. When these two objects get collision or during the collision, they will apply force on each other. You can do experiment of this at home. You can take two balls and firstly move the first ball, indicate that any particular color, and after that push the second ball towards that ball. It will strike to this, and at that time this ball will also apply a force on this ball, and second ball or B ball also will apply the force on A ball. It means that force on ball or object A applied due to B, it will be FAB. It will apply force in this direction. Here I indicate FAB. And force applied on B due to object or ball A, it will be in this direction. Hence it will be FBA. Okay. Newton's third law of motion says that action is equals to an opposite reaction, or every action has equal and opposite reaction. It means these force will be equal in amount but will be in different directions. Here I shows the negative sign which shows the direction only. Magnitudes are same of both forces. Now impulse of FAB means impulse of this force. For a short duration time, it will be FAB delta T, because impulse is nothing but it's a force for a little time. F delta T, it will be equals to change in momentum. Also, impulse of FB will be equals to FBA delta T. Now, it is before collision, during collision, and it is after collision. Now, impulse of FAB, it is change in momentum m1 v1 because of A object here. M1 is the initial mass and it is constant. V1 is the final velocity. Here M1 is the mass which is constant. U1 is the initial velocity. You can subtract final minus initial to get the change. M1 V1 minus M1 U1. Similarly, impulse of FBA will be equals to change in momentum. It will be M2 V2 minus M2 U2. V2 is the final velocity after collision and U2 is the initial velocity of object B here. Now, but this equation says that it will be equal and opposite, Hence, change in momentum will be FAB delta T will be equals to minus FBA delta T. Here it will equals to it. M1 V1 minus M1 U1 will be equals to minus of M2 V2 minus M2 U2. Here, what you will find, it will become M1 V1 minus M1 U1. It will be equals to minus M2 V2 plus M2 U2. This quantity will come in this side, become positive, and this will go to that side. Here M1 V1 plus M2 V2 will be equals to M1 U1 plus M2 U2. These are the velocities have particular direction. It is the total linear momentum. Understood? It is the total linear momentum after collision.